Okay, let's move into talking about the unit circle. I was interested to learn last year with some of my students. They thought the unit circle was sort of just a thing for remembering where various important angles are, but unit circle is a circle whose radius is 1. So 1 unit, that's where the unit part comes from. So its radius equals 1, whatever unit we're using. I don't know, it could be centimeters, meters, furlongs. It's 1 unit, so that's the unit circle. And we use this to define, this is one way of thinking about sine and cosine. Sine of an angle theta is opposite over hypotenuse. Remember these things? Cosine of theta equals adjacent side over hypotenuse. Tangent opposite over adjacent. A lot of people have neat mnemonics for remembering these. I always remember it's SOHCAHTOA. I don't know, it sounds like some Polynesian island. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Another one, good one, is Oscar had a heap of apples. Remember, it goes O-H-A-A. Oscar had a heap of apples. Alright, and then there's also, let's see, Olean High School. I don't know. You can make up whole bunches of things. But these help you remember these, and this is sort of this triangle here on this unit circle. And there are lots of ways to think about sine and cosine. And now that we know imaginary numbers, we'll learn some other ones. So this is our angle theta. This is the opposite side. This is the adjacent side. And this is the hypotenuse. Alright, you recognize your triangle, and immediately the one formula that everyone remembers pops into your head. And for that one, we'll call this A, B, and C. It's a good old Pythagorean Theorem. A squared plus B squared equals C squared for a triangle. The Pythagorean Theorem. Wonderful, beautiful equation. And a gateway to some very difficult problems. I'm always fascinated by what integers you can use to solve this. You can solve it for, on the unit circle, this side h, c is going to be equal to 1. And what happens here is these lengths end up being the same as sine and cosine. So this, if this is 1, then this length here is actually sine of theta. It's going to be less than 1. So as you go around this circle, this part's going to get longer. So if we were to graph this out, if we start at angle equals 0, sine equals 0, and it goes up. It goes up till you get to 90 degrees, and then it's at the top, and then it comes back down. It's to 90 degrees, so here's the angle. Here's sort of a hand, a watch hand going backwards, sweeping out these angles. Eventually it goes negative. Let me draw over that figure, and comes back up here, making one full circle. If you look the other way, sort of draw a sideways graph here. If you look at this distance, this starts out as 1. And this distance here, as this angle gets bigger, here this distance is this big. As the angle gets bigger, it's this big. It gets smaller and smaller. Till it goes here, then it goes negative. It Comes back around. Sorry, I've run out of room here. And you get this. If you draw that on the side, you get this, which is a graph of sine from 0 to 360, or 0 to 2 pi. Okay? I'm sorry, yeah, that's cosine. And similarly, sine of 2 theta. If you don't remember anything else, remember these two graphs. You can do a huge amount of things with these two graphs. Sine of theta looks like this. Okay? Two wonderful graphs, very important. We can get them from imaginary numbers too. Well, we'll see that later on. Today we'll work with them just with our regular triangle. Well, we'll stick in the first quadrant with acute angles. You can see as they go larger than 90 degrees, larger than pi over 2 degrees, you can get negative numbers out of these things. Alright? This is one way to think about sine and cosine and tangent of theta. Tangent of an angle. We're going to be working with these things a lot. They are wonderful things. A lot of phenomena in nature are periodic. You can think of this as being the temperature in Jamestown. Right now we're probably about here. The temperature is coming up and we're starting in the new cycle again if we're looking at it like this. Temperature is going to go up till we get to July. Actually, there's a bit of a lag in temperature. It actually gets warmer, I think, in August. And then it drops back down. It's not coldest in December, it's coldest in February. So this is a periodic function here. And you can think of this as day length. Right now, as we come up to the, not the vernal equinox. Yes, vernal equinox, vernal meaning spring. Day length is almost the same as the length of night. Eventually, as you go into summer, it gets longer and longer. So periodic functions are all over in nature and in science. Rotating. What some people don't notice, and it's sometimes surprising, is if you have a rotating, say you have like a, I don't know, old-fashioned record, and you had a bug on the record just sitting there. The distance out here, its position in this sort of y direction goes as a sine function, and its position in the x direction goes as a cosine function. So these cosine and sine functions are all over the place. You probably remember bunches of this. You have your own mnemonic all set here. So we'll do a few things with this. There are 3 important angles that we'll talk about really quickly. Well, let's draw it like this. There are 2 important triangles and 3 important angles. One is, and I really love these. I'd say like 90% of the problems deal with these kind of triangles. In this triangle, these 2 angles are the same. These are both right triangles. And these are both 45 degrees. Or pi over 4. Let's write radians in red. 90 degrees is pi over 2. 45 is half of 90, which is pi over 4. So both pi over 4. And in this one, the smaller one's 30, and the bigger one's 60. So you know that in triangles, all the angles add up to 180. So these are the 2 most important triangles. If these are the same angle, then these lengths are the same. Also we'll write these as pi over 6. And this one's twice that one, 2 pi over 6 or pi over 3. That's another way to write those. So I didn't draw this very well. Should have been a little flatter, I think. One like this. That's a little better. That's 30, 60. Alright, so using your Pythagorean theorem, you can quickly get sine, cosine, and tangent here. You know that a squared plus b squared equals c squared. So if these are the same length, we'll just set them equal to 1. Because our triangle's the same whatever proportion length we have here. And then we get 1 squared, which is 1, plus 1 squared equals the hypotenuse here, equals c squared, which equals equals 2, which equals c squared or h squared, depending on how we write it. So c is square root of 2. We want to get c squared equals, we have c squared equals 2. C equals, take the square root of both sides. We get c equals square root of 2. So this is 1 square root of 2 triangle. And then we get sine of 45 equals 1 over square root of 2. And also cosine of 45 equals 1 over square root of 2. Okay, you probably remember that. Tangent is opposite over adjacent, which is 1 over 1. Tangent of 45 equals 1. Okay, you can think of that as being inscribed in sort of a big circle here. Well, we'll do that for another time. Similarly, for this triangle, for a 30-60 degree triangle, the shortest side is half the distance of the longest side. So the longest side is the hypotenuse. You can see how this one's going to be longer than that. So that leaves this side being, say this is A, B, and C. A squared plus B squared, 1, equals C squared, 2 squared. Equals 2 squared minus 1 squared, which equals 4 minus 1, which equals 3. A squared equals 3, so A equals square root of 3. So that's the 1, 2 square root of 3 triangle. That's 30, 60, 90. Or pi over 6, pi over 3, 90. I think we still say 90. Alright, so for knowing that, and since these are just ratios, I'm going to draw like that because I didn't flatten it on. Notice if you double this triangle, you would double the lengths of the sides. So it's really just the ratio of these things that are important. So if this is 30 degrees, sine of 30, Oscar had, is opposite side. So if this is the angle, this is the opposite side over hypotenuse. So it's 1/2. Cosine of 30. Hopefully this is all sort of review for you. Cosine is the adjacent side. Square root of 3 over 2. And then tangent of 30 is 1 over square root of 3. Similarly, you can find the things for 60. For 60, these two things will be reversed, and this will be flipped over. Alright. 2 very important triangles, 3 very important angles. 30, 60, 90, and 45, 45, 90 triangles. Pi over 6, pi over 3, pi over 4. I don't expect you to memorize these things, but I think working with them enough, you will memorize them. For the final things, for tests, I will let you have a card or so where you can write down, you can draw your triangles so you don't forget them. Okay, so I don't want you to really memorize these, but be able to find them quickly and work with them. 30, 60, 90, sort of in this unit circle. We You have these sines and cosines. That's one way of thinking of sines and cosines. Next, we'll take them out of the acute range and take them into the other quadrants. Okay? Your old friends are back with you.